Happy New Year, everyone. It's Christina from the Glaser Tutoring Company. It's the first week of the new year that I'm making this video, so I just wanted to wish you all a happy new year, and I hope you guys had a holiday season that was filled with love and laughter, and yeah. But now we got to get back to business, right? So we're going to get back to business by solving these wonderful system of equations, right? We have two equations here. So we have 7 over 3x minus 1 over 6y equals 2. And then we have negative 21 over 6x plus 3 over 12y equals negative 3. And somehow we have to take these two equations and we got to solve them. Now, what does that actually mean? Well, by looking at these two equations, they are linear lines. Both of the x values are only raised to the first, and both of the y values are only raised to the first. So if you have x and y's in an equation, and you don't have x squares or y cubed or any other number besides 1, you know that these are linear lines. And the solution, right, or hopefully the solution, because there could be different answers, if these linear lines intersect each other, x marks the spot. That is your solution. So what we're solving for is we're basically solving for a point. It could be one point, right, in which these linear lines intersect. There could be infinite amount of points, or there could be no points. So those are your three answers. So maybe we're looking for a single point, which means that we're looking for just an x value and a y value. They come in a coordinate pair in which these two equations intersect. Now, these are called a system because if you have any two equations, two or more equations, that are just, communicating with each other, or they just put it into, a fancy question like this, that's just classified as the system. Okay. So there's many different ways to solve a system of equations. You got substitution method, addition, elimination. Usually the substitution method is the easiest, but usually we only use substitution method if you only have an x equals right away or a y equals. In this case, both of our x's and our y's are being multiplied by, in this case, fractions. Yikes. So I wouldn't really do the substitution method. The other way is you gotta get the numbers in front of either the x or the y the same. Because what you're going to do is you're going to cancel one variable out so that you could work with the other variable, right? Usually, and all the time in algebra, we always have an answer of x equals and y equals, not x and y equals. So that's why you have to cancel one of these out. But you can only do that if the numbers in the front are the same. Now, we will be multiplying these equations. So we're going to say this is equation, or maybe I'll say this is just number 1, and this is equation number 2. Now, since both of these values in front of either the x or the y are different, we know that we have to multiply at least one of them. And we just try to make it easy for ourselves, right? Now, in this case, 7 over 3 and 21 over 6, those are a little bit bigger numbers. So usually the bigger the number for me, it could be a little bit more challenging. Here I have 1 over 6 and 3 over 12. I'm going to try to get my y values equal to each other. Now, I notice that they do have common numbers in between them, right? For the denominator, 6 and 12, right? I could just take a 6 and times it by 2, and then 6 can go into 12. The same thing for the numerator, right? I have a 1 and I have a 3. I could just take a 1 and times it by 3 to get a 3, right? So in essence, what we're doing is we're going to try to get this number into 3 over 12. And we're going to do it just like as we just said. We're going to times this equation by, let's see. Now, we definitely need a fraction, right? So what I'm going to do is I'm going to pull this over just so that we have a little bit more room. And we know that we have to times it by a fraction, right? And now let's just work on the denominator, right? 6 times what will get me 12? Yeah, I could times the denominator by 2, which means that the bottom number has to be a 2. 6 times 2 will get me 12. Now I do the same thing for the numerator, right? 1, I want to turn it into a 3. So 1 times what will get me a 3? Yeah, a 3, right? And there is your number. We're going to times the equation by 3 over 2. But you gotta be fair, which means that if I'm multiplying this by 3 over 2, I have to multiply the whole entire equation by 3 over 2. So that means this 7 over 3, I gotta take that 7 and times it by a 3, because that's the numerator number, and I have to take the bottom number and times it by a 2. And the same thing goes for this guy, right? This 2, I have to times it now by 3 over 2. So let's set it up, right? We have equation 2. Actually, no. We have equation 1 that we are manipulating. 7 times 3 is 21. 3 times 2 is 6. Minus, and that's an x value, right? We'll do the same thing for this guy. 1 times 3, we got a 3 on the top. 6 times 2 is the 12, and that's the y value. And this is now going to equal, in this case, you can simplify, right? You've got a 2 in the numerator, you got a 2 in the denominator, so that goes bye-bye. And you just got a 3 left over, so this would be equal to 3. Now, we didn't have to do anything with equation 2, so let's just write that out. Equation 2. And equation 2 is negative 21 over 6. This is getting interesting. That's times by x plus, and this is a minus 1, right? Because that was a negative, so the negative stays. And this is 3 over 12y. This is getting real interesting. And now this equals negative 3. I didn't do anything with the equation number 2 because we didn't have to. And now we have the same values, but one is negative and one is positive. So how am I going to get rid of these y's? Am I going to add them together? Or am I going to subtract them? What do you think? If I have a negative and a positive, I must, yeah, you got it, add them together. So technically, if you are adding, it is classified as the addition method. But sometimes teachers or professors, if you're getting rid of one variable, they just classify it generally as the elimination method. It doesn't really matter. Just make sure that you get rid of one of your variables. But in this case, I'm going to add both of my equations together, and let's see what I get. But now this is interesting because I have 21 over 6 minus 21 over 6. That goes bye-bye. Oopsie. I got rid of my x values. And I'm going to get rid of my y values because, 3 over 2, negative 3 over 2 plus a positive 3 over 2. Oopsie, that goes bye-bye as well. I lost both variables. So we got 0, big fat 0, equals 3 plus a negative 3. That's a big fat 0 as well. So let's just take note as to what just happened. We lost both variables. So this is a very special case. When you lose both variables, and you're just dealing with numbers now across your equal sign, you either have two answers. The answer is either these two linear lines have no solutions, or they have infinite amount of solutions. How to determine what's the answer? Well, the answer is the mathematical equation that's given. Does this mathematically make sense? Does 0 equal 0? Yeah, they're literally the same number. So this is a big fat yes. And that means that this has an infinite, it has an infinite amount. Infinite number of solutions. And that actually means that these are the same equation. They are the same equation, but just written differently. The other way, if you had no solutions, this would be like 0 equals a negative 1. The mathematical expression does not make sense because 0 isn't negative 1 and negative 1 isn't 0. So that would be a big fat no, and then you would say that you would have no solutions. In that case, you have parallel lines. Very, very special case of lines that never intersect. But in this case, 0 equals 0. So you got an infinite number of solutions. It's the same equation, same line, and that's it. I hope this helped. Let me know in the comments. Thank you so much for viewing the video. Like the video, tell your classmates, tell your friends about this channel. Just gets the word out there in the YouTube universe that this channel actually exists. Thank you so much for coming here for your educational needs, and keep studying hard, all right? I know you guys got this. Good luck on your tests and quizzes. And yeah, let's kick this new year off to a great start, all right? Also, I would like to give a huge shout out to Maricela. Thank you so much for being a member to the channel. Your support means a lot to my brother and me, and we're thrilled to have you be a part of this amazing community. Memberships are open on the channel, and if you want to become a member, just click that join button, which can be found below on any video if you're watching on your desktop, or it can be found on the overall channel page too. For all of you that want your name shown in the video, don't forget to choose the gold tier or higher. Thank you so much for considering, and have a great day. Talk to you in the next lesson. Bye-bye!